Comprehensive review of DeepSeek. Part 1. Expanding strengths. 1. Natural language processing, NLP, ability. As an advanced language model, DeepSeek has very powerful capabilities in the field of natural language processing. This AI can analyze complex texts, understand language structures, and even answer complex questions. This ability allows DeepSeek to perform near human-like in areas such as machine translation, text summarization, and content generation. Machine translation. DeepSeek is able to translate texts into different languages. These translations are not only grammatically correct, but also semantically close to the original text. This capability has made DeepSeek a valuable tool for people who deal with foreign languages. Text summarization. DeepSeek can provide summarized versions of long texts. This feature is especially useful for people who do not have enough time to study long texts. DeepSeek can extract the key points of the text and present them in a concise and useful way. Content production. DeepSeek is able to generate new texts based on the input data. This capability is especially useful in areas such as marketing, journalism, and writing. DeepSeek can produce articles, reports, and even short stories. 2. Deep learning and adaptability. DeepSeek is designed based on deep learning algorithms, which allow it to improve its performance over time and by receiving more data. This adaptability allows DeepSeek to perform well in various fields such as medicine, law, information technology, and even art and literature. 3. Access to extensive information. DeepSeek is connected to a huge database that includes up-to-date and diverse information from around the world. This access to extensive information allows DeepSeek to provide accurate and up-to-date answers to users. 4. High speed in information processing. One of DeepSeek's strengths is its high speed in processing information. This AI can answer users' questions in a fraction of a second and extract the information needed. This high speed has made DeepSeek an efficient tool for users who are looking for quick and accurate answers. 5. Ability to produce creative content. DeepSeek is able to produce creative texts such as poetry, stories, and even programming codes. This ability has made DeepSeek not only used as an information tool, but also as a creative tool. 6. Support for multiple languages. DeepSeek supports different languages, which increases the access of users from all over the world to this AI. This capability has made DeepSeek a global tool that can meet the needs of users with different languages. 7. Personalization capability. DeepSeek can personalize its answers and suggestions based on the specific needs of users. This capability allows users to have a better experience in interacting with this AI. Comprehensive review of DeepSeek. Part 2. Expanding weaknesses. 1. Dependence on input data. One of DeepSeek's weaknesses is its strong dependence on input data. If the input data is incomplete or incorrect, DeepSeek's responses may also be incorrect or misleading. This issue can be problematic and provide misleading answers, especially in areas such as medicine or law, where the accuracy of information is of paramount importance. This can lead to wrong decisions. 2. Lack of full understanding of the concept of meaning. Although DeepSeek has a high ability in natural language processing, it is still not able to fully understand the concept of meaning in the way that humans understand it. This issue causes that in some cases, DeepSeek's answers lack the necessary depth and insight. DeepSeek's lack of deep understanding may not be able to correctly understand deep and complex concepts. This issue can lead to superficial answers. DeepSeek's lack of understanding of emotions is not able to understand human emotions. This issue causes DeepSeek to perform poorly in emotional interactions. 3. Limitation in real creativity. Although DeepSeek can produce creative texts, this creativity is based on predetermined patterns and existing data. In other words, DeepSeek is not able to create completely new and original ideas in the way that humans can. DeepSeek may not be able to create completely new and original ideas. Dependence on existing data in DeepSeek to produce content can lead to the production of repetitive content. 4. Ethical issues and biases. DeepSeek, like any other artificial intelligence, may be affected by the biases present in the training data. This issue can lead to the presentation of biased or discriminatory answers. In addition, The use of DeepSeek in sensitive areas such as surveillance or judicial decision-making can have serious ethical issues. 5. Limitation in emotional interactions. DeepSeek is not able to understand or respond to human emotions. This issue causes DeepSeek to perform poorly in emotional interactions or situations where there is a need for empathy and understanding of emotions. 6. Dependence on technology infrastructure. DeepSeek's performance is highly dependent on technology infrastructure such as servers, communication networks, and computing resources. Any disruption in this infrastructure can affect DeepSeek's performance. 7. Limitation in independent learning. Although DeepSeek is able to learn and adapt, this learning is not yet done independently and without the need for human intervention. This issue causes DeepSeek not to be able to fully learn from its experiences and improve. Comprehensive review of DeepSeek, Part 3, Comparison with other AIs. Compared to other AIs such as GPT-4, Gemini, or Claude, DeepSeek has its own advantages and disadvantages. In terms of natural language processing ability and response speed, DeepSeek is at a high level and can compete with other advanced models. However, in some areas such as real creativity or understanding emotions, DeepSeek may lag behind its competitors. 1. Comparison with GPT-4. GPT-4 is one of the most advanced language models developed by OpenAI. Compared to GPT-4, DeepSeek performs better in some areas such as response speed and access to extensive information. This capability allows users to have a better experience in interacting with DeepSeek. However, GPT-4 may perform better in areas such as real creativity. This issue allows GPT-4 to create completely new and original ideas. In the field of understanding emotions, GPT-4 may perform better. This issue allows GPT-4 to perform better in emotional interactions. DeepSeek has access to more extensive information. This capability allows DeepSeek to answer users' questions with high accuracy. 2. Comparison with Gemini. Gemini is an AI developed by Google that is based on the Lambda language model. Gemini is considered one of DeepSeek's main competitors due to its access to Google's extensive data and advanced capabilities in natural language processing. Compared to Gemini, DeepSeek performs better in some areas such as response speed and personalization, and this capability allows users to have a better experience in interacting with DeepSeek. But Gemini may have advantages in areas such as access to up-to-date information and integration with Google services. Personalization in DeepSeek is able to personalize its answers and suggestions based on the specific needs of users. This capability allows users to have a better experience in interacting with DeepSeek. Gemini, due to its integration with the Google search engine, has access to more up-to-date and extensive information. This capability allows Gemini to provide more accurate answers to users' questions. Integration with Google services in Gemini such as Google Docs, Gmail, and Google Calendar can perform better in areas such as time management and content production. 3. Comparison with Claude. Claude is an AI developed by Anthropic that is designed based on ethical and human principles. Claude is considered one of DeepSeek's important competitors due to its focus on ethics and reducing biases. Compared to Claude, DeepSeek performs better in areas such as response speed and access to extensive information, but Claude may have advantages in areas such as reducing biases and adhering to ethical principles. This capability allows Claude to provide fairer and more impartial answers. In general, DeepSeek has more extensive information than Claude. This capability allows DeepSeek to answer users' questions with high accuracy. Comprehensive review of DeepSeek, Part 4, Challenges and Opportunities Ahead. 1. Challenges facing DeepSeek. Despite its many strengths, DeepSeek faces several challenges that require attention and improvement. Some of these challenges include data biases. DeepSeek may be affected by biases in the training data. This can lead to biased or discriminatory responses. To address this challenge, there is a need to develop algorithms that can identify and mitigate data biases. Limitation in understanding emotions. DeepSeek is unable to understand or respond to human emotions. This makes DeepSeek perform poorly in emotional interactions or situations where empathy and understanding of emotions are needed. To address this challenge, there is a need to develop algorithms that can understand and respond to human emotions. Dependence on technology infrastructure. DeepSeek's performance is highly dependent on technology infrastructure such as servers, communication networks, and computing resources. Any disruption in this infrastructure can affect DeepSeek's performance. To address this challenge, there is a need to develop stronger and more stable infrastructure. Limitation in independent learning. DeepSeek is not capable of independent learning without the need for human intervention. This prevents DeepSeek from fully learning from its experiences and improving. To address this challenge, there is a need to develop algorithms that can learn and improve independently. 2. Opportunities ahead for DeepSeek. Despite the challenges ahead, DeepSeek also has many opportunities for improvement and development. Some of these opportunities include improving emotion understanding. By developing more advanced algorithms, DeepSeek can improve its ability to understand and respond to human emotions. This capability will allow DeepSeek to perform better in emotional interactions. Reducing biases. By developing algorithms that can identify and mitigate data biases, DeepSeek can provide fairer and more impartial answers. This capability will allow DeepSeek to perform better in sensitive areas such as medicine and law. Independent learning. By developing algorithms that can learn and improve independently, DeepSeek can improve its performance over time. This capability will allow DeepSeek to learn from its experiences and improve. Integration with other services. By integrating DeepSeek with other services such as Google Docs, Gmail, and Google Calendar, it can perform better in areas such as time management and content production. This capability will allow users to have a better experience in interacting with DeepSeek. Comprehensive review of DeepSeek, Part 5. The future of DeepSeek. Given the rapid advances in technology, it is expected that DeepSeek will improve over time and address its weaknesses. In the future, DeepSeek can become a powerful and adaptable tool that plays an important role in various fields. Some of the areas where DeepSeek can play an important role in the future include medicine. DeepSeek can help doctors diagnose diseases, prescribe medications, and manage patients. This capability allows doctors to make more accurate and faster decisions. Law. DeepSeek can help lawyers analyze cases, extract laws, and provide legal advice. This capability allows lawyers to make more accurate and faster decisions. Information technology. DeepSeek can help programmers generate programming codes, debug, and optimize codes. This capability allows programmers to increase their efficiency and productivity. Art and literature. DeepSeek can help artists and writers produce works of art and literature. This capability allows artists and writers to create new and creative ideas. Questions and rumors. Part 6. Questions and rumors about DeepSeek. Rumor. DeepSeek is an open source AI. Is DeepSeek an open source AI? No, DeepSeek v3 is not an open source AI. Currently, DeepSeek v3 is a proprietary model developed by DeepSeek, a company specializing in artificial intelligence and natural language processing. This means that the underlying code, architecture, and training methods of DeepSeek v3 are not publicly available for modification, redistribution, or independent use by the general public. Why is DeepSeek v3 not open source? Proprietary technology. DeepSeek v3 is built using advanced machine learning techniques, including deep learning and large-scale language models. These technologies are often considered intellectual property and are protected to maintain a competitive advantage in the AI industry. Open sourcing such technology could lead to misuse, loss of competitive edge, or unauthorized commercial exploitation. Resource investment. Developing an advanced AI model like DeepSeek v3 requires significant resources, including computing power, data, and expertise. Companies like DeepSeek make heavy investments in research and development to create these models, and open sourcing them could undermine the return on investment that sustains further innovation. Control and quality assurance. By keeping the model proprietary, DeepSeek can maintain control over its deployment, update, and quality assurance processes. This ensures that the model is used in a way that aligns with ethical guidelines, safety standards, and the company's intended use cases. Commercialization. DeepSeek V3 is likely part of a broader commercial strategy that involves offering AI services, APIs, or products to businesses, developers, and end users. Open sourcing the model could disrupt this business model, as it allows others to replicate or redistribute the technology without compensation. Open source alternatives. While DeepSeek V3 itself is not open source, many open source AI models and frameworks are available in the AI community. Some notable examples include GPT-NeoX and GPT-J. These are open source alternatives to models like GPT-3, developed by organizations like Eleuther AI. They are freely available for use, modification, and development by researchers and developers. Llama, Large Language Model Meta AI. Developed by Meta, formerly Facebook, Llama is a collection of open-source large language models designed for research purposes. Hugging Face Transformers. Hugging Face provides a wide range of open-source models and tools for natural language processing, NLP, including BERT, T5, and others. These models are widely used in the AI community for various applications. TensorFlow and PyTorch. These are open-source machine learning frameworks that allow developers to build and train their own AI models. While they are not pre-trained models like DeepSeek V3, they provide the necessary tools to create custom solutions. Benefits of open-source AI. If DeepSeek V3 were open source, it could offer several benefits. Transparency. Open sourcing the model allows researchers and developers to examine the code, understand how it works, and identify potential biases or vulnerabilities. Collaboration. The AI community can contribute to improving the model, fixing bugs, and adding new features, leading to faster innovation. Accessibility. Open source models are more accessible to smaller organizations, researchers, and individuals who may not have the resources to develop their own AI systems. Customization. Users can modify the model for their specific needs, such as fine-tuning it for specialized tasks or integrating it into unique applications. Why DeepSeek might not open source its model. Despite the advantages of open source AI, there are valid reasons why DeepSeek might prefer to keep DeepSeek V3 proprietary. Competitive advantage. Maintaining proprietary control over the model allows DeepSeek to differentiate itself in the market and offer unique value to its customers. Monetization. By keeping the model closed, DeepSeek can monetize it through licensing, subscriptions, or API access, which helps fund further research and development. Ethical and safety concerns. Open sourcing a powerful AI model could lead to misuse, such as generating harmful content, spreading misinformation, or enabling malicious activities. Keeping the model proprietary allows DeepSeek to implement safeguards and monitor its use. Support and maintenance. Proprietary models often come with dedicated support, documentation, and regular updates, which may be more challenging to provide in an open source environment. Conclusion about DeepSeek being open source. DeepSeek V3 is not an open source AI model. It is a proprietary system developed by DeepSeek, designed to offer high-performance natural language processing capabilities while maintaining control over its use, quality, and commercialization. While open-source AI models offer transparency, collaboration, and accessibility, proprietary models like DeepSeek V3 offer unique advantages in terms of innovation, monetization, and ethical oversight. The choice between open source and proprietary AI ultimately depends on the goals and priorities of the organization developing the technology. Rumor: DeepSeek is an AI that does not require powerful hardware. Is DeepSeek really an AI that, like other AIs, does not require powerful hardware? Is DeepSeek an AI that does not require specialized hardware such as NPU for processing? DeepSeek, as an advanced artificial intelligence model, requires powerful hardware to operate optimally. This need for powerful hardware is due to the complexity and high volume of computations required to train and run large language models, LLMs, like DeepSeek. Here's a look at the issue. 1. Need for powerful hardware to train the model. Training large language models like DeepSeek requires very powerful computing resources. This process involves heavy matrix calculations, processing massive amounts of data, and running deep learning algorithms. Some of the hardware requirements for training such models include graphics processing units, GPUs. GPUs are essential for training large language models because of their ability to perform parallel computations. Advanced GPUs such as NVIDIA A100, V100, or H100 are typically used. These GPUs have thousands of computational cores that can perform heavy mathematical operations quickly. Tensor processing units, TPUs. TPUs, developed by Google, are specifically optimized for machine learning and tensor computations. These units can dramatically increase the training speed of large models. Memory, RAM, and storage. Training large language models requires a large amount of memory, RAM, and storage space. For example, models like GPT-3 or DeepSeek may require hundreds of gigabytes or even terabytes of memory and storage space. High-speed networks. In distributed training environments, where model training is done on multiple devices, high-speed networks such as InfiniBand are essential for transferring data between devices. 2. The need for powerful hardware to run the model. After training the model, running it also requires powerful hardware, although this need is usually less than the training phase. Some of the hardware requirements for running large language models include GPU or TPU for inference. To run large language models in real time, GPUs or TPUs are usually used. This hardware can perform heavy computational operations quickly and provide quick responses to users. Memory, RAM. Large language models require a lot of memory due to the large volume of parameters, e.g., billions of parameters. For example, running a model with 100 billion parameters may require tens of gigabytes of memory. Central processing units, CPUs. Although GPUs are preferred for running large language models, powerful CPUs can also be used to run smaller models or in environments where GPUs are not available. 3. The difference in hardware requirements for training and running. Training large language models requires much more powerful hardware because it involves heavy calculations and processing of huge amounts of data. This process may take days, weeks, or even months and require hundreds or thousands of GPUs or TPUs. Inference. Running the model after training requires less powerful hardware because it only includes the calculations needed to generate responses. However, for very large models, GPUs or TPUs are still needed to generate responses in a reasonable time. 4. Alternative solutions to reduce the need for powerful hardware. Although DeepSeek and similar models require powerful hardware, there are solutions that can reduce this need. Using smaller models. Some smaller models, such as Distilbert or TinyGPT, that are created through compression or knowledge distillation can be run with less powerful hardware. Model optimization. Techniques such as quantization, reducing the accuracy of calculations, or pruning, removing unnecessary parameters, can reduce the size and complexity of the model and reduce the need for powerful hardware. Using cloud services. Companies like DeepSeek may offer their models as cloud services. In this case, users do not need to have powerful hardware and can access the model through the internet. 5. Conclusion on the hardware required for DeepSeek. DeepSeek, as an advanced artificial intelligence model, requires powerful hardware for training and running. This need is due to the high volume of computations and data required for optimal model performance. However, solutions such as using smaller models, model optimization, and using cloud services can reduce this need. Ultimately, the choice of appropriate hardware depends on the user's goal, training, or running, and the resources available. Rumor. The response and information processing speed in DeepSeek is very low compared to other artificial intelligences. How fast is DeepSeek's response speed compared to other artificial intelligences? The response and processing speed in DeepSeek depends on several factors, such as the hardware used, the size of the model, the optimizations performed, and the type of task the model performs. Compared to other artificial intelligences such as GPT-4, Gemini, or Claude, DeepSeek can perform faster in some cases, but this depends on the conditions and execution environment. We will examine this issue in more detail below. 1. Factors affecting response and processing speed. The response and processing speed in DeepSeek and other AI models depends on the following factors. Hardware used. Using advanced GPUs or TPUs, such as NVIDIA A100 or Google TPU V4, can significantly increase processing speed. If DeepSeek is run on such hardware, it can provide faster responses. Model size. Larger models, such as DeepSeek with billions of parameters, require more calculations, and their response speed may be slightly slower. However, optimizations such as compressed models or knowledge distillation techniques can improve speed. Task type. Some tasks, such as generating short text or answering simple questions, are performed faster, while more complex tasks, such as translating long texts or generating creative content, may take longer. Software optimizations. Using optimized libraries such as TensorFlow, PyTorch, or JX can increase processing speed. Also, techniques such as quantization, reducing the accuracy of calculations, or pruning, removing unnecessary parameters, can also improve speed. 2. Comparing DeepSeek's speed with other artificial intelligences. Compared to other large language models, LLMs, such as GPT-4, Gemini, or Claude, DeepSeek speed can be better or similar in some cases. This comparison depends on the following conditions. A. Response speed in simple tasks. DeepSeek. In simple tasks such as answering short questions or generating short text, DeepSeek can provide quick answers, especially if it is run on powerful hardware. GPT-4. GPT-4 also performs quickly in such tasks, but due to the larger size of the model, it may be slightly slower than DeepSeek. Gemini and Claude. These models also perform quickly in simple tasks, but their speed depends on the hardware and optimizations performed. B. Response speed in complex tasks. DeepSeek. In more complex tasks such as translating long texts or generating creative content, DeepSeek's speed may be slightly reduced, but it can still perform well. GPT-4. Due to its larger size and greater complexity, GPT-4 may be slower in such tasks. Gemini and Claude. These models may also have lower speeds in complex tasks, but the optimizations performed can reduce this problem. C. Speed in cloud environments. DeepSeek. If DeepSeek is provided as a cloud service, the response speed depends on the cloud infrastructure and communication networks. In this case, DeepSeek can provide fast responses. GPT-4 and Gemini. These models are also provided as cloud services, and their speed depends on the cloud infrastructure. In this area, the speed difference between DeepSeek and these models may be negligible. 3. Optimizations done in DeepSeek. DeepSeek may use the following optimization techniques to improve response and processing speed. Compressed models. Using smaller models that are created through knowledge distillation or compression can increase speed. Quantization. Reducing the accuracy of calculations, e.g., from 32 bits to 16 or 8 bits, can increase processing speed and reduce resource consumption. Pruning. Removing unnecessary parameters from the model can reduce the size of the model and improve processing speed. Parallelization techniques. Using parallelization techniques in data processing can increase response speed. 4. Conclusion on the response speed or information processing section in DeepSeek. Response and processing speed in DeepSeek depends on several factors such as hardware, model size, task type, and optimizations performed. Compared to other artificial intelligences such as GPT-4, Gemini, or Claude, DeepSeek can perform faster in some cases, especially if powerful hardware and advanced optimizations are used. However, in more complex tasks, the speed difference may be negligible. Ultimately, choosing the right model depends on the user's needs and available resources. Rumor: the cost and budget for building DeepSeek AI is much lower than other AIs. What was the budget for building DeepSeek AI compared to other AIs? The budget for building large AIs such as DeepSeek, GPT-4, Gemini, and other similar models is usually not announced accurately and publicly, as this information is often considered confidential company details. However, based on estimates and reports available on the development costs of large language models, LLMs, some approximate figures can be mentioned. Below, I will examine the potential costs of building DeepSeek and compare it with other artificial intelligences. 1. Costs of building large AIs. The costs of building large language models like DeepSeek include several main parts. A. Computational costs, training costs. Training large language models requires a huge amount of computation. These costs include the following. Hardware costs, using hundreds or thousands of advanced GPUs or TPUs, such as NVIDIA A100 or Google TPU V4, each of which has high costs. Electricity and energy costs. Training large models requires a lot of energy. For example, training the GPT-3 model is estimated to have consumed about 1287 megawatt-hours of energy, which is equivalent to significant costs. Cloud costs. If cloud services such as AWS, Google Cloud, or Microsoft Azure are used, computing costs can reach millions of dollars. B. Data costs. Collecting, cleaning, and processing training data also has significant costs. These costs include data collection, buying or collecting large data sets from various sources, data processing, cleaning, labeling, and preparing data for model training. C. Human resources costs. The research and engineering teams working on developing large language models usually include data scientists, machine learning engineers, and experts in related fields. The salary and wage costs of these teams also form a significant part of the budget. D. Research and development are winking and laughing costs. Researching and developing new models and improving existing models also has high costs. These costs include numerous experiments, optimizations, and development of new algorithms. 2. Estimating DeepSeek's construction costs. Although accurate information about the DeepSeek construction budget is not available, based on the known cost for similar models such as GPT-3 or GPT-4, estimates can be provided. Training costs. Training large language models like GPT-3 is estimated to have cost between $4 and $10 million. For larger models like GPT-4, this cost can reach $20 to $100 million or more. If DeepSeek is similar in size and complexity to GPT-3 or GPT-4, it probably had similar costs. Data and human resources costs. The costs of data collection and hiring research teams can also reach several million dollars. Research and development costs. Research and development costs can also reach $10 to $50 million or more, depending on the time and resources required. 3. Comparison with other artificial intelligences. Compared to other large artificial intelligences, DeepSeek's construction costs are probably in a similar range. Some of the known costs for other models include A. GPT-3 AI, OpenAI. Training cost, about $4 to $10 million. Overall costs, including research and development, data, and human resources, overall cost can reach $20 to $50 million. B. GPT-4 AI, OpenAI. Training cost, estimated to have cost more than $100 million. Overall costs, including research and development and other costs, this figure can reach $200 to $500 million or more. C. Gemini AI, Google. Training cost. Gemini is based on the Lambda model. Lambda training costs were probably similar to GPT-3, about $10 to $50 million. Overall costs, including research and development and other costs, this figure can reach $50 to $100 million. D. Claude AI, Anthropic. Training cost. Claude is also based on large language models. Its training costs were probably in the range of $10 to $50 million. Overall costs, including research and development and other costs, this figure can reach $50 to $100 million. 4. Conclusion on the DeepSeek budget section. The costs of building large artificial intelligences like DeepSeek, GPT-4, Gemini, and Claude are very high and are generally estimated to be in the range of tens to hundreds of millions of dollars. These costs include computational, data, human resources, and research and development costs. Although accurate information about the DeepSeek construction budget is not available, given its size and complexity, its costs are likely in a similar range to GPT-3 or GPT-4. Ultimately, these high costs reflect the huge investment of companies in developing advanced artificial intelligence technologies. Rating and Ranking, Part 7, DeepSeek Rating and Ranking. Based on the available information and comparisons made in various fields, such as speed, accuracy, creativity, adaptability, and ethics, an approximate score can be assigned to DeepSeek and other artificial intelligence. Of course, This scoring is entirely relative and depends on the user's needs and evaluation criteria. Below, scoring is done based on key criteria. Scoring criteria out of 10. Processing and response speed. Output accuracy and quality. Creativity and content production. Adaptability to various tasks. Bias reduction and adherence to ethical principles. Accessibility and ease of use. AI scoring. 1. DeepSeek. Processing speed. 9 of 10 due to hardware and software optimizations. Accuracy and quality. 8.5 of 10, excellent in general areas, but needs improvement in some cases. Creativity. 8 of 10, ability to produce creative content, but limited to training data. Adaptability. 9 of 10, support for different languages and diverse application areas. Bias reduction. 7.5 of 10, still affected by data biases. Accessibility. 8 of 10, dependent on cloud services and requires powerful hardware for local execution. Overall average is almost equal to 8.3 of 10. 2. GPT-4 OpenAI. Processing speed. 8.5 of 10, high speed, but slower than DeepSeek in some tasks. Accuracy and quality. 9.5 of 10, best performance in natural text generation and answering complex questions. Creativity. 9.5 of 10, unrivaled in producing creative content and new ideas. Adaptability. 9.5 of 10, support for hundreds of different applications. Bias reduction. 7 of 10, similar ethical challenges to DeepSeek. Accessibility. 7 of 10, limited access to paid API and requires high costs. Overall average is almost equal to 8.5 of 10. 3. Gemini, Google. Processing speed. 8 of 10, dependent on Google services and communication networks. Accuracy and quality. 8.5 of 10, especially in accessing up-to-date information. Creativity. 8 of 10, good ability, but less than GPT-4. Adaptability. 8.5 of 10, integrated with the Google ecosystem. Bias reduction. 7.5 of 10, efforts to reduce biases. Accessibility. 9 of 10, free and integrated with Google tools. Overall average is almost equal to 8.2 of 10. 4. Claude, Anthropic. Processing speed. 8 of 10, average performance compared to competitors. Accuracy and quality. 8.5 of 10, focus on logical and structured answers. Creativity. 7.5 of 10, less suitable for artistic content. Adaptability. 8 of 10, suitable for data analysis and consulting. Bias reduction. 9 of 10, high focus on ethical and human principles. Accessibility. 7 of 10, limited access to paid API. Overall average is almost equal to 8 of 10. 5. Llama, Meta. Processing speed. 7.5 of 10, suitable for academic research. Accuracy and quality. 7.5 of 10, good performance in basic tasks. Creativity. 6.5 of 10, weak in producing creative content. Adaptability. 7 of 10, limited to research applications. Bias reduction. 6.5 of 10, needs improvement in bias reduction. Accessibility. 9 of 10, open source and free. Overall average is almost equal to 7.3 of 10. Conclusion on DeepSeek score compared to other AIs. DeepSeek, with an average of 8.3 of 10, is a competitive artificial intelligence that has excellent performance in areas such as speed and adaptability, but needs improvement in bias reduction and creativity. GPT-4, with a score of 8.5 of 10, is still the leader in accuracy and creativity. Gemini and Claude, with scores close to DeepSeek, are also considered tough competitors. These scores are based on available data and public comparisons and may vary in specific circumstances. Choosing the best model depends on the user's needs, speed, accuracy, creativity, or ethics. Final conclusion. DeepSeek, as an advanced artificial intelligence, has significant strengths that have made it a powerful tool in various fields. Natural language processing capabilities, high speed, and access to extensive information are among the main advantages of DeepSeek. However, this artificial intelligence, like any other technology, also has weaknesses that require attention and improvement. Dependence on input data, lack of full understanding of the concept of meaning, and limitations in real creativity are among the challenges that DeepSeek faces. Compared to other artificial intelligences, DeepSeek performs better in some areas, but may lag behind its competitors in others. However, given the rapid advances in technology, DeepSeek is expected to improve over time and address its weaknesses. Ultimately, DeepSeek, as a powerful and adaptable tool, can play an important role in the future of technology and human interactions.